Thank you, hello. So for everyone interested in F#, I won't be showing much F# code. I think there will be like 3 lines, but if you want, we can talk about it later. It's more about showing the idea and showing the business process as well, because I think what's lacking for me sometimes here, it's real-world applications, and I want to show you that functional programming has real-world applications and that it has applications that are running in production for several years. So something about me, well, I'm a mathematician for a long time, got my degree in mathematics, and by lucky accident, I got into functional programming. I wasn't really given a choice. It was like, we have like 1,000 lines of F#, so you better learn it. So I did, and yeah, I'm super happy about it. Wanted to update my LinkedIn, but instead I went for extra 2 beers, and it was a good decision. But anyway, you can add me there if you want. And about the company where I work, what is workforce management? Imagine that you have insurance company that has a call center, and it would be like 100, 200 operators taking calls from customers who have some problems and wants to deal with it. So there are many steps that you can make. First step is like you predict how many customers are going to call at each time for a month, for example. We do this prediction using some machine learning techniques. Then you optimize the roster. So at every time of the day, you have like as many agents responding to the calls as you need based on those predictions. And then you validate this roster, like you use labor code, there are some rules, and you can make some analysis, like how good is the roster. And then finally, we have like statistic reports and payroll exports for the customers. So it's customizable per every single customer, and usually our customers have several hundred employees. Like in Poland, we have AXA Insurance, and for example, in Czech Republic, because we're based in Prague, we have like T-Mobile, we have Albert, which is hugest store for supermarkets, so there's like 50,000 people there. So yeah, you can find a link there. And what my team, well, it's me and one extra colleague is doing, we're optimizing those shifts. It's a mathematical problem of shift scheduling optimization. What are the inputs? The inputs would be predefined shifts. For example, some employee says that he wants to work on a given day exactly that shift. Then there will be requests for holidays. Somebody's going in midsummer for a week for holidays, so he puts the request and manager approves it or decline it. So it's there. There's the workload forecast. So that's the number of people that are going to call center, for example. And there are business and labor code rules. So the labor code rule would be like there can be at most 6 consecutive shifts. And the business rule would be like employees should work at most 1 weekend in a month. And the output is what we claim to be optimized roster. we try to optimize it as good as we can. I'll get to it. So yeah. This can be input, for example. You can see there are some shifts already filled in. There are some requests for holidays. Yeah. Then this would be workload forecast. For each day, we have like how many calls are going to come. We also predict how long those calls are going to be, and we also spread it to like 15 minutes intervals. And this is like what the result looks like. So you can see like every employee has much more shifts, and you can see there's analysis of coverage of service level. This means like how well is the demand satisfied. If there's a red line, it means more people are calling than we can handle the calls. If there's a green line, it means there are more people than we actually need. If it's blue, it's optimal. So this might be the result. And how it works. Firstly, we load data from database. It takes, well, several seconds, and then the optimization process can last, for example, for an hour. So we don't want to use database all the time, except for logging. And then we go through calculation phases. How many of you are familiar with linear programming? Okay, some of you. So it's like optimization technique where you have set of variables. For example, you have x, y, and z, and you put linear constraints on them. For example, you have x plus y is less than 2, and then you have like z is less than 3, and then you have a function that you're trying to optimize, and that would be like x plus y plus z, for example, and you're looking for optimal solution for this. It's important that everything is linear, And this problem is when you have continuous variables, it can be solved in linear time. But when you have integer variables or binary variables, it's NP hard. And we are using external software for that. It's pretty expensive, but you can see how we use it is that we have generated like different variants of shifts. For example, for employee 1, he can work from 8 to 4 p.m. or he can work from 9 to 5 and so on. And we have like millions of combinations, and every shift is a binary variable. So when it is set to 1, that means employee will be working. When it is set to 0 in the result, it means employee won't be working. And we just put that into a solver, which acts kind of like a black box. And then we get a result and we process it. So what we are doing is building this model that we put into black box. So it's data processing. And as you can see, we're doing it in phases because optimizations has to be split sometimes, because it's not feasible to run it all at once with like millions of variables. And how it looks like, this model creation is that based on the workload I was showing, number of calls, we create some needs, then we create all the variants of the shifts that employee can work. Then there might be some modifications, and then we create constraints. The constraints come from the rules. So for example, if we have the rule that are at most 6 consecutive shifts, then it would be like for each, 6-day or 7-day interval, it would be like sum of the variables is at most 6. That would be like the easy constraint. Or if we have like at most 2 weekend shifts per month, then we would take set of all weekend shifts for employee and we would sum them. And it would be like some of those has to be less or equal than 2. So this is how you can imagine what we're trying to create. And we have something about 40 different rules that are like custom implemented with business logic. And each of them is like several hundred lines of code. So why we decided to go functional, it wasn't my decision. When I came to the company, already started to be functional, because you've seen it, it's a pipeline, it's data processing pipeline. We just load the data from database, then we process it, and the data is not changed. For example, if we load employee with ID 42, it's highly unlikely that we want to change ID of the employee in the process. And also it is that you can see there are multiple phases after each other, so we don't want to make mutations like between those phases. That would be weird if something changed. So it is functional pipeline, and we want to remove like any possibility of different side effects that just, I mean, I have a good example. Well, this is the only code example that you're going to see. And like the left one is C# class. You can see this is for part of the shift, and it has its datetime interval. Then it has its type, which means what activity is employee working on. For example, in a shop, it can be like he's working on cash desk, or he's working at bakery or stuff like that. So this is the activity type, and then it's got reference to its like parent roster item, which is the whole shift. And we had a bug where we were trying to modify the activity, and instead of creating a new part with injected new activity, we would just modify ID of the activity, and therefore in all other phases, the ID of activity would be modified, and we just like couldn't figure out what's the bug. And then when we found it, we just like realized that there wasn't copy helper with the Lambda that was changing ID. It was just changing ID, and was like super stupid. So now that we are changing it into F# records that are immutable, it is impossible to happen. So I think like this was for me the biggest motivation, that if you find something that is mutable, it will get mutated and it will result in a bug. So the solution layout thing is, it's interop between C# and F#. The main service that is loading data from database and running the calculation is written in C#, even after the refactor. So like more people can work with that. And you can see there are rules, or there are just like, does this work? No, it's barely, yeah. So you can see there are rules in F# and rules in C#. That was like the old layout. And it's basically having 2 projects on like the same level, but it means like one project has to reference other. So either put like C# above F# or other way around, and it always leads into places where you don't want to be because you cannot have circular reference in .NET solutions. So that's one reason for unifying it. How it looks now is all the rules have been rewritten to F#. So like this level is fixed. What is still there, we have entities, as I was showing, for example, the part, there are like C# classes. And those entities are first, there are database entities. Then once we load the data from database, we convert it to C# entities. And then it's like a step between that, and then they're converted to F# entities because those C# entities are serialized, and we don't want to really serialize F# entities. That's like a company policy or stuff like that. There are really some buggy stuff with F# serialization, so options and stuff like that. So it's like a safety feature more or less, but this is how it could be if we had only the entities in F#. But yeah, it's got some problems. Okay, so what are the prerequisitions for refactoring? Yeah, you should know what the code should do. That's a good start, so you know what's right. Then there's knowing what the code does. That's not as important. Actually, we often don't know what the code does, and usually when you don't know what the code does, it's doing something wrong, or it's not important. You will see some customer will come complaining if you change it. Then you should have trust in your ideas. I mean, last Lambda days, I was talking about this idea with somebody, and he told me, yeah, just go for it. We did something similar and it worked. And I was like, yeah, it has to work because F# is Turing complete, so it cannot go wrong. And when I submitted abstract, well, it wasn't working, but I got accepted, so I was like, okay, I have to do it, and it works now. It's in production. Then you have lots of time. I will get to that, and then you need solid tests, and I'll get to that as well. So how was the refactoring process looking? Refactoring of the rules, I think the whole solution started back in like 2012 maybe, and from 2015 the rules were written in F#. And as it was like I was talking about roughly like 40 rules, and each could be like 500 to 2,000 lines of code with really hard business logic. So it took several years to refactor them to F#, but at the end of the last year we got to the point where we were having everything, like all the rules in F#. Then we had to refactor the data structure. You can imagine the data structure as like one class that has collections. So for example, we have like data class, and has like list of employees, list of activities, list of employee requests and stuff like that. So I changed that to F# record. So it was like F# record, and the fields were activities, employees, and stuff like that. And I did that using firstly interface, so I could see what could be like read-only, and then I made F# record implementation. So that was one part, and that was quite easy. I thought it would be more difficult, and then the difficult part was refactoring the entities. So I, for example, made implementation for employee as a record or for roster item as a record, with allowing as little mutability as possible. Like often it was already immutable, or there were no setters used, but this one was very challenging, and if you want to go into details with me, I'll be happy to explain it to you. I think it doesn't really make sense to explain to somebody who didn't really see F#, but there's stuff like mutually recursive type that you have to update. And I think I've seen it in just like one blog post. And there's also like caching fields on records. And that's one thing that ChatGPT told me that it is impossible. And I was like, okay, but let's do it. and I did it. And this is like a really cool one. I haven't seen that like anywhere. So I can go into details with that. And there were associated refactors, and I think I'll skip that for now, maybe if we had time, but okay, and this like the main takeaways for me are the simplicity is the key, and if you have code that is not used, then you can delete it. And you have to make a good tool for analyzing it. For example, we used a tool where we accessed all the customer databases, and we took out all the rules and all the parameters, and we went through all the values that were there, and we've seen what is used and what is not. Because if a rule has a bool parameter that has like 2 different values, then one value can lead to 200 lines of code. And if nobody is using it, you can delete this code, and you don't have to look for bugs in it. So that's a very important one. And also, deleting is much faster than refactoring. I love deleting. I mean, it might be a subjective thing, but I just love deleting code. Another thing is like, don't discard ideas that seem too simple. When I see that I'm going to refactor something and it's written in a very difficult way, I try to find as simple solution as it is. And well, it rarely happens it stays that simple all the way. So I'm just like lucky that I didn't go for something that could be more robust. It's just like try to solve things as simple as it's possible. And final one is that you don't write code for yourself. And this is especially important in F# and C# co-op, because we have like 2 or 3 colleagues that are able to read F# and everybody else is in C#. So it's kind of stupid to be selfish and use very cool language features like writing your own monad. It's like you come across this part of code like once in a year and you forget what it does, and like nobody else knows what it does. We had like monad that allowed us to run asynchronous computations that could be paused from outside. It was never really working. It took like, I don't know, 2,000 lines of code, and it was like everything was wrapped twice because of it. And I think it, I don't know, took us maybe like 3 weeks just to delete it. But it's like, if you think you're doing something fancy that you're not sure that everybody will understand, don't do it. And it's also like, if you're doing code review or something, you're the person that's doing the code review who has to understand it. You shouldn't like trust the guy who wrote the code that it will work. If you don't understand it, nobody else will understand it. So that's the one. And then finally, the tests. So we have 3 types of tests. We have simple unit tests for like small methods, small algorithms. Then we have generated tests when you have, for example, to generate intervals when you want to check something there. We're using fscheck. I'm not sure if anybody tried using fscheck. Okay, for me, like anytime I'm trying to generate a data structure that's a bit more complex, it's, for example, datetime interval, or datetime, it would give me like 0, 0, 0, 0, no matter how I try to randomize it. So I ended up just generating integers and then generating everything from integers. That was like pretty funny one. And then crucially, input data unit tests. So when I told you that we just take the data from database and we convert it to some entities, for every computation that is running for every customer, we have this data serialized so we can debug it later. And if we find a problem in some computation, we take this data, that is anonymized of course, and we can create tests of it, which runs the whole computation, and we can write a custom unit test. At this point, we have like maybe 70, maybe more of those tests, and they're absolutely invaluable. So when I was doing this refactor, I was writing code for 1 month, and then it took me like 2 weeks to fix all the tests. And like, if I wouldn't fix the test, it would mean that there would be some issues coming from customers. So you want to have a test that you rely on, and if I wouldn't have them, I think I would never just do the thing or would be able to trust myself. So I think, I'm not sure if we have time, it's like exactly 4, so.
Yeah, I'm not sure either, but thanks, Daniel. So